Hi everyone, and welcome to the Mat 211 review on matrix inversion and determinants. My name is Julia and I work for the tutoring centers at ASU. So, given A, our matrix A here, we want to find the determinant and then we want to find the inverse matrix if it exists. And what this means, if it exists, not all matrices have inverses. So we're going to see what that means in a moment. But first, let's talk about determinants. So finding determinants can be somewhat of a long process depending on the size of your matrix. But if we have 2 by 2 matrices, so 2 rows and 2 columns, there exists a kind of nice shortcut. So for a moment, let's talk about some matrix M, which is a 2 by 2 matrix. And we're going to say that its values are A, B, C, and D. That's a D. There we go. And so if we want to look at the determinant of M, which we would notate as like M with these bars on either side. So, or you could also write it as determinant of M. That's also commonly used. But if we want to find the determinant of M, and provided that M is a 2 by 2 matrix, then what we do is we multiply the two values on the left diagonal going top to bottom. So A times D. And then we subtract from that the product of the two values on the right diagonal going top to bottom, which is B times C. So this little shortcut makes trying to find the determinant a whole lot faster. Now, if we have a determinant of M and it does not equal 0, so any other value besides 0, then M is invertible, meaning that it has an inverse for M exists. M -1, that's an E, exists. However, if M, or the determinant of M equals 0, then M inverse does not exist. So it's important to look for cases where it equals 0, because there's no point in trying to find an inverse if it already doesn't exist. So this is a nice quick trick for checking that. So let's go back to our matrix A here. Let's make a little space for our scribbles. We'll just leave our notes up here at the top. I'll just rewrite them. So again, M equals A, D minus B, C, or the determinant of M, that is. All right, so we want to find the determinant of A. So we can say that to write it out down here, that's going to be the determinant of 1, 0, 5, and 3. And that's going to be 1 times 3, so just lining up our A and D here from our formula. So 1 times 3 minus our diagonal in this direction, that product, which corresponds with our B and our C here. So that's going to be 5 times 0. And this means that we have 3 minus 0, or 3. So since our determinant of A is equal to 3, which is not equal to 0, we know that A is invertible. So now let's talk about how to find the inverse of A. For 2 by 2 matrices, we have a nice shortcut for that. So let's make a little space here again. So if we want to find A inverse, and A is a 2 by 2 matrix, then the inverse of A is 1 divided by the determinant of A times, so it's the values on the left. Actually, let's make this M, just so we can use our A, D, and yeah, that'll be nicer. Let's do that instead. So we're going to find the inverse of M here. So since we have an A and a D here, we flip the row of the values on the left diagonal, going top to bottom again. So we're going to have D in the first row, first column, and A in the second row, second column spot. Now for the other diagonal, the B and C, we're going to negate those values. We're not going to flip them. We're just going to put negative signs in front of them. So we have 1 divided by the determinant times this kind of jumbled around version of our original matrix. Let's make that D look nicer. There we go. All right, so let's go ahead and do that for our A. Now we already know what our determinant is. So we have A inverse equals 1 over the determinant of A, which is 3 from here. And then let's go ahead and use this rule to flip our values around. So in the A spot, so if this was A here for our original, that's going to go down to this corner. And our 3, which was down in that corner, is going to come up to this corner, just like these two. And then we're going to take 5 and 0, and we're going to negate them. So -5 and, well, 0, because -0 is still 0. So now we can go ahead and multiply this scalar value by our matrix, which results in 1, -5 over 3, 0, and 1/3. So that is our inverse. So we have A equals 3 as our determinant, and this matrix as our inverse of A. So before I go, I just want to remind you all that if you're looking for any additional tutoring or academic support services at ASU, you can go to the Tutoring Center's website at tutoring.asu.edu. And all of our resources will be listed there. Additionally, if you're looking for specific tutoring services for your course, you can use the tutor search tool, which you can find at our main page or by going to this full link here. So thanks so much and have a great rest of your day.